Bright Tuty. Every student matters.
Show that each angle of a rectangle is a right angle. What is a rectangle? In a rectangle, we have got opposite sides equal, right? As in every parallelogram. Rectangle is a parallelogram with one angle equal to 90 degrees, right? And if one angle is 90 degrees, it is also a parallelogram. So opposite angle will be equal and it will be equal to 90 degrees. Now it is a parallelogram, so I can say that this angle, if this is alpha, then their sum will be 180 because these are co-interior angles. So alpha plus 90 is equal to 180. Hence alpha is also 90. And if alpha is 90, the opposite angle will definitely be equal to 90 because it is a parallelogram. So every angle of a rectangle is a right angle. Okay. And you started this with that rectangle is a parallelogram with one angle equal to 90 degrees. Okay. Show that diagonals of a rhombus are perpendicular to each other. Now in case of a rhombus, all sides are equal and rhombus is also a parallelogram, so diagonals bisect each other. So what we know about a rhombus is that this segment is equal to this segment, this is equal to this, and all four sides are equal to each other. Now if you consider these two triangles, this one and this one, you can notice by these bars itself that these two triangles are congruent triangles by SSS congruence criterion, right? Because three sides of this triangle are equal to three sides of this triangle. So the angles opposite to equal sides of these two triangles will be equal. What I mean is that angle opposite these three bars, the side which is denoted by these three bars, this angle, if this is theta, then this angle will also be theta. And we know that these two are linear pair, right? So 2 theta is equal to 180 degrees. Hence I can say theta is equal to 90 degrees. So this is how easy it is to show that the diagonals of a rhombus are perpendicular to each other. If theta is 90, it will mean that these two diagonals are perpendicular to each other. So these angles are 90 degrees. Okay. ABCD, ABC is an isosceles triangle, okay, in which AB is equal to AC. So that means the angles, this angle, if this is theta, this angle will also be theta because these are angles opposite equal sides of a triangle. AD bisects exterior angle PAC. So this side AD bisects this angle. That means if this is alpha, this will also be alpha. Show that angle DAC is equal to angle BCA. What is angle DAC? This is alpha. What is angle BCA? Theta. So we need to show that alpha is equal to theta. And ABCD is a parallelogram. This is what we need to show. Okay. Now this is an exterior angle. So it will be equal to the sum of opposite interior angles. So this 2 alpha, that is this angle, will be equal to sum of these two angles. So 2 alpha is equal to theta plus theta, that is 2 theta. Hence alpha is equal to theta and the desired result is there. Okay, this is how easy you can visualize it. Now I leave the writing of steps to you because these are just examples. This is not an exercise. So this much portion, my duty is to make you understand each and every step, make you understand each and every concept, right? But you have to write all these steps yourself. So theta is equal to alpha. I proved the first part. Now ABCD is a parallelogram. Once you see that alpha is equal to theta, you can say that alternate interior angles are equal. Hence AD is parallel to BC. So AD is parallel to BC. Why? Because alternate interior angles are equal. Okay, alternate interior angles are equal, right? We have proved that AD is parallel to BC, and it is given in the question that CD is parallel to AB. So opposite sides are parallel. For second part, I can say AD is parallel to BC, proved in part 1, right? And CD is parallel to BA. It is given in the question. So pair of opposite sides are parallel to each other. Hence I can say ABCD is a parallelogram. Okay. Two parallel lines L and M are intersected by this transversal P. Show that quadrilateral formed by bisectors of interior angles is a rectangle. Okay. So we need to show ABCD is a rectangle. Okay. So to show it to be a rectangle, it will be enough to show that ABCD is a parallelogram and one of the angles of this parallelogram is 90 degrees, right? Now L is parallel to M, right? So I can say that this angle here and this angle, these two angles are co-interior angles and their sum is 180 degrees. So angle, let us name these angles as angle 1 and angle 2. So angle 1 plus angle 2 is equal to 180 degrees. Co-interior angles are supplementary, right? Okay. Now this angle is half of this angle 1, right? So this angle, if I name it as theta, it is half of angle 1, and this angle, if I name it as angle alpha, it is half of angle 2, because these are angular bisectors. These are bisectors of interior angles. That is, this line is bisector of this angle and this line here is bisector of this angle. So alpha is half of angle 2, theta is half of angle 1. So what I can say here is, if I divide this equation by 2, 1 plus 2 by 2 is equal to 90 degrees. So half of angle 1 plus half of angle 2 is equal to 90 degrees. Hence alpha, half of angle 2 plus half of angle 1, that is theta, it is equal to 90 degrees. Hence the third angle, that is this angle of this triangle, will be 90 degrees, because we know theta plus alpha plus angle B is equal to 180 degrees by angle sum properties of a triangle. So angle B is equal to 90 degrees. This is what you can find pretty easily. Now one thing is clear, right? One thing is clear, that one of these angles is 90 degrees. Now I just need to show that these lines are parallel. That can also be done very easily, because this angle 1, this full angle, is equal to this angle, let it be angle 3. Okay. Why are these equal? Because these lines are parallel, it is already given, and these are alternate interior angles. So this angle 1 is equal to angle 3, angle 1 is equal to angle 3, because these are alternate interior angles. So what can you say about half of these angles? Half of angle 1 will be equal to half of angle 3, right? What is half of angle 1? It is theta. What is half of angle 3? Let it be beta. Okay. So theta is equal to beta, and these are alternate interior angles for these two sides, this side and this side. Hence these are parallel. Hence AB is parallel to CD. After this you will write this. So AB is parallel to CD. Similarly, you can go about these angles. So this angle is equal to this angle. Why? Because these are alternate interior angles. So their halves will also be equal to each other, right? Hence these angles are also equal, and these are alternate interior angles, so this line will be parallel to this line. So line BC will be parallel to line AD. Similarly, so ABCD is a parallelogram with one angle equal to 90 degrees, hence a rectangle. So quadrilateral ABCD is a rectangle. Show that the bisectors of angles of a parallelogram form a rectangle. So what is given is that ABCD is a parallelogram and these are angular bisectors. So if it is alpha, this will also be alpha, this is beta, this part will be beta, this part, right? This is alpha, so this one is also alpha. If this part, and we know that this is a parallelogram, so opposite angle, angle B will be equal to angle D. So this angle B will also be 2 alpha, right? It will be equal to 2 alpha, and this is angular bisector, so each of these angles will be alpha. Similarly, you can show that these two angles are beta each. Now once you have shown this much, you can see that these two lines are parallel. Now you see that 2 alpha plus 2 beta, 2 alpha plus 2 beta is equal to 180 degrees. Why? Because if you look at angle D and angle A, these are co-interior angles for these two parallel lines CD and BA. So their sum is equal to 180 degrees. Hence, I can say alpha plus beta is equal to 90 degrees. And now in this triangle, in this little triangle here, these two angles, their sum is 90 degrees. The third angle will have to be equal to 90 degrees to meet the angle sum property, right? So if this is 90, this angle is also 90. Similarly, alpha plus beta is 90, so this angle is 90, hence this angle is also 90, right? So opposite angles are equal. These two opposite angles are equal. This is one thing. And secondly, so we have shown that these two angles are 90 degrees. Now look at this triangle, triangle DRC. In this triangle DRC, this angle is alpha, this angle is beta, right? And this is the third angle, angle R. So angle alpha plus angle beta plus angle R is also 180 degrees. And what is angle alpha plus angle beta? It is 90 degrees. So angle R is also 90. So this angle is also 90. Hence this angle will also be 90 degrees. So I have shown that PSRQ is a quadrilateral with each angle equal to 90 degrees. Now we know that opposite angles are equal, so this is a parallelogram and one angle is 90 degrees, hence it is a rectangle. So it is a parallelogram with all angles equal to 90 degrees, hence it is a rectangle, right? So this is how you can deal with this question here. ABCD is a parallelogram in which P and Q are midpoints of opposite sides AB and CD. Now it is given that ABCD is a parallelogram, so opposite sides AB and CD will definitely be equal to each other, right? And P and Q are midpoints, so this segment here is equal to this segment. AP is equal to PB because P is midpoint, and DQ is equal to QC because Q is the midpoint, right? So this segment is equal to this segment. Now let me show you that when AB is equal to CD, half of AB will be equal to half of CD, correct? So what I can say is that AP is equal to PB, DQ is equal to QC, and AP, PB, DQ, QC all are equal to each other. So I'll mark it by 2 bars here. What I mean to say is that AP equals PB equals DQ equals QC, right? Another thing that I want to highlight here is that ABCD is a parallelogram. So AB is parallel to DC. Hence, I can also notice that AP is parallel to QC, right? DQ is parallel to PB, right? When these two lines are parallel, their segments will also be parallel, right? Right? This is what I wanted to say here. Now, let us look at the next part. If AQ intersects DP at S, okay, and BQ intersects CP at R, show that APCQ is a parallelogram. APCQ. Now, in quadrilateral APCQ, we can notice that AP is equal to CQ and AP is parallel to CQ. And we know that if a pair of sides of a quadrilateral is equal and parallel, then this quadrilateral is a parallelogram. Then this quadrilateral is a parallelogram, right? So APCQ is a parallelogram. When you say these two results, that AP is equal to CQ, that means opposite sides, one pair of opposite sides is equal and they are also parallel. AP is parallel to CQ. When you say these two things collectively, you will say that APCQ is a parallelogram, right? This is a property of parallelogram, that if a quadrilateral has got one pair of opposite sides as equal and parallel, then this quadrilateral will be a parallelogram. And due to that, the second pair of sides, opposite sides, will be equal and parallel. Okay, so it is enough to say that one pair of sides is equal and parallel for a quadrilateral to be a parallelogram. Similarly, you can show that DPPQ is a parallelogram. Why? In DPBQ, you can notice that PB is equal to DQ and PB is equal to DQ. So, I will just write the hint here. Let me write it here. In quadrilateral DPBQ, BP is equal to DQ or QD and BP is parallel to QD. Hence, DPBQ is a parallelogram. Now that we have shown that DPBQ is a parallelogram, then this DP will also be parallel to BQ. When DPBQ is a parallelogram, the other pair, that is DP and BQ, they will also be parallel, right? Now, DPBQ is a parallelogram, APCQ is a parallelogram. So, AQ is parallel to CP because APCQ is a parallelogram. DP is parallel to BQ because DPBQ is a parallelogram. So, I am looking at the third part here, right? I was just giving you the hint of third part, that PSQR is a parallelogram. For PSQR, what is PSQR? This one. Why would it be parallelogram? Because PR will be parallel to SQ and PS will be parallel to QR, right? So, because of these two results, I can say AQ is parallel to PC, AQ is parallel to PC because APCQ is a parallelogram, APCQ is a parallelogram. And the second result, what I can say is PD is parallel to BQ, PD is parallel to BQ because of the DPBQ being a parallelogram, right? When you know these two things, you mean that these lines AQ, PC, if these are parallel, then SQ will be parallel to, then this segment will be parallel to PR. So, SQ is parallel to PR because of this and PS is parallel to QR because of this result here, and collectively this will tell you that PSQR is a parallelogram. PSQR is a parallelogram, right? Because both the pairs of opposite sides are parallel to each other, hence this quadrilateral PSRQ is a parallelogram. PSQR is a parallelogram. Alright,